From ContainerDays Hamburg, this video is proudly presented by Dux IT.
I'm doing Kubernetes security for more than 10 years, and normally only in critical infrastructure. And then came the German government, and I had also some work for the German government, and the cloud strategy of the German government has some of my fingerprints. If they would realize that this is something they can implement and get sovereign, this would be nice. So I'm mostly doing DevSecOps, and I start on that level where you say, okay, make a threat model. So we normally start with a threat model. If you don't have a threat model, then all your efforts may go into the wrong direction. And one part of it is we try to implement, and I gave a talk on this on ContainerDays some years ago, about defense in depth. So you need multiple layers of security, and they should be independent. And there should be redundancy if one of these controls fails. So if you have get hacked or your container is hacked, there should be other means that protect you from somebody taking over your entire cluster. And I gave this talk, so this is a kind of repetition. Can my cluster be owned? And I made some exemptions. My example normally is image tragic, because this is a wrong version of image magic, which executes commands in the image. And this means you can create a kubectl command if you install a kubectl in a container by uploading an image. So this is simpler as log4shell or something like this. And then you need access to the service account. You can install software. You always can install software in the temp directory, because the temp directory of a container is always writable. And then you can take over it, and if some of your colleagues does a role binding to the cluster admin, and you have the service account token, then you own the cluster. This is pretty straightforward. There's a demo available some years ago. And what you see is, who is responsible for this? So the application, everybody runs applications which have flaws, libraries. I have a customer now who is doing FFmpeg, and FFmpeg is a highly optimized C library, and you cannot believe that a highly optimized C library is secure, even if no CVEs are detected, so you have to isolate it. The service account is there by default. You can immediately, if you don't run an operator, remove the service account from your pod, and you should do it. And you should prevent the installation of software. This is the responsibility of the developers, so this is what you should do in all your projects, and this is unexpectedly and notoriously difficult to argue, because developers say, this is a standard container. Red Hat says we have our UBI images, and always a curl is inside this this universal base image containers. Curl is nearly omnipresent, which is good because it's a good product, but it should not be in a container if you don't need it. And you get total control, cluster admin role is exploited, or some other privileged account. And there are examples from the early days of the internet where you can install clusters, and they simply say, use the cluster admin role for your deployment because it's easier. Yes, it's easier, but it's also easier to hack the cluster. Examples, log4j, you see you have a netcat as a command line. You can use netcat to create a backward connection, and then you have a shell in your container. Spring is notorious for this. And a non-Kubernetes example here, you see you do a Java-lang runtime, get runtime exec on curl on some input stream. So then you have a remote code execution in your container, and you can execute an arbitrary command, and if you get a connection to the network, you can exploit your cluster and the entire cloud network. And this can be expensive. There is a full demo for this. Effectively, I hit this problem 30 years ago because it was a Ghost script problem, and it was a flag in the compilation of Ghost script. And from time to time, this reappears and comes back from the dead. There's a Jupyter notebook on GitHub. You can get all the links in the presentation, and then you can test on your own if your cluster is vulnerable to this kind of attacks. And yeah, I already mentioned standard images. This is like, yeah, you make everything, you buy an important and expensive lock, and then you put the key under the doormat. You have compliance, software bill of material, which covers now all licenses and versions, but then somebody asks you, are we really clean? Can we distribute our code? Can we publish our code? Or can we publish the service of our code? And security asks, are we affected? And at that time, when Log4Shell was around, then somebody asked me, yeah, are we affected? Yeah, my answer was, look into your SBOM. What is an SBOM? Are you using Java? Yes, then you are probably affected with a probability of 80%, so yes. This is a Tomcat, and this is a Tomcat scan in Harbor with Trivy, and this is a standard thing. And if you look here on the side, there are severity high and critical bugs inside it, but they don't come from Java libraries. They come from curl, old versions of lib3 type, old versions of anything. And then you have a discussion in your project. And in DevSecOps, this means you have developers, you have security people, and you have operations people. And then the normal procedure would be, if you would release every 6 months, yes, go through the list and then mark them as does not affect us, which is difficult if you want to release daily. It's extremely difficult. So my advice in critical infrastructure, this is where I can enforce it, is please get rid of all these bugs and shrink your containers if possible. If you have a Tomcat container, you are not interested in curl or Python security. And the tools are attack tools themselves. So if you can get kubectl from curl and make it executable in temp, then you have more or less access to the cluster API with your dev4 service account. This, the worst argument is it's blinding security. So you have typically, in my experience, the record was 730 vulnerabilities in one container. So containers are still used as virtual machines, and then you have a compiler in it. It's nice to have a GCC in it. You could even do, and yeah, nobody wants to maintain the CVE or CVE ignore list for a reason. Okay, then let's do the hardening. Kick out everything which is not needed. What is not needed? You have to know it. This could be done by a script at build time of the container. Yes, you could use a positive list of files you want to have. This is an example I did some years ago, and also in the links on GitHub. It is, as usual, as the Guinea pig using the standard Nginx from Alpine, and it's hardening. There's a hardening script. The hardening script, by the way, is in Bourne shell, not in Bash, because Nginx likes Bourne shell. And then you have to make this list of, positive list of programs. And as a feature, I included something that also depending dynamic libraries are automatically included into this. So if you use standard C dynamic linking, you only need to do it. You get an entry point for Nginx and not all this shell around it. And then the container shrinks to 6 megabyte from 190. This is obviously too difficult to do it in every project for everything, because you also have these things. You have to do it for every programming language. And this is the .NET example. You have to call all these libraries again, and then the /app ASP NetApp directory where the .NET libraries live. Then you can do more or less the same and bring down the container to a small percentage of the original one. Okay, then some people came up, and as a surprise on GitHub, this project appeared for Docker containers, and they have created a tool which is called Bluffs for container debloating. And they create, what they do effectively is, and this is the only way to do it right, they created a shadow file system on top of the container file systems. This means in one step, a shadow file system is created, and then the container image, which is used by the running container, only uses the shadow file system. And they log all the access to files in this shadow file system. So effectively, you get this positive list I asked you to create on your own behalf for free, and then you can get a positive list and have a shadow container, which is in a later step debloated, and you get only the binaries and the configuration files you need. This is a proof of concept. It's for Docker only. And I started with it on my laptop, and then immediately the screen got black because it uses a systemd inside the container. This kills the terminal. And as a side effect, it restarts the dockerd 2 times during the process and is therefore unusable out of the box. So I, was a little bit disappointed. Yes, this is the right way of doing it, but they are not very experienced with it. And what I then noticed, nearly half a year later, then I looked back into it because effectively I did a CFP for this talk because I just wanted to show this. And then, now I have to do something. And then I found out, it also works in an Ubuntu 2204 with Docker, which is exactly the version which is used in Minikube. So it's usable in Minikube because Minikube does effectively the same. It runs more or less a virtual machine as a Docker container, and I can use it and I can communicate with the Minikube installation of Kubernetes inside. It's a terrible hack, but effectively it shows as a proof of concept what it should show. I needed 2 scripts, one inside Minikube and one outside Minikube, to go through the entire debloat cycle. It's terribly slow, therefore I don't give live presentation, but it works this way. So in Minikube, there's an unblowed pipe, which is effectively using a socket, and this orchestrates all these debloating, what these guys have done and given to us. And then there is a pod event listener. So there have been 3 rainy days in Berlin in July. It runs outside Minikube, and effectively the task of the pod event listener is to detect new pods. It's an operator written in Bash. Don't do it. And the only thing it does is it sends the name of the image to the unblowed pipe script inside the Minikube container. And then it patches the owner of the pod. So if there is a deployment, it patches the deployment to use now the unbloated image. And this stop triggers the deep load process inside, and then it's restarted with a patched image. And if you see the sequence diagram, which is probably nearly correct, you'll see how it's complicated. Some user creates a pod, then a shadow image is created. The shadow image is tagged as slash buffs, and then same with no buffs, and then what you should never do in a Kubernetes environment, retagging an image behind the kubelet, so the kubelet does not notice that something is going retagged. This is the hackish part. And then the Docker daemon has an event queue, tells, yes, now the image is used, and we can start patching the container, and then the container is patched and used for a certain time so that you get the information actually which files are used inside the container. And then again, the owner is patched, the pod is restarting in this process, and then you get this limited, also this debloated image up and running. Okay, let's go to the numbers. This is what I've tested so far. This is from the original paper. What I can confirm, I've checked it. So partially you have a reduction between 95 and 65%. So all these the stateless systems have a good chance of being 95% reduced, not only Nginx, but also HTTP. They used Postgres and MySQL as databases, and Memcached and Redis. So this all goes down to at least 2/3. Okay, and finally, this is what I would recommend is that somebody goes into it, because I don't have the time to make a product out of the proof of concept. Just if you are interested in this, make an improvement to buffs, which is actually not restarting the Docker daemon, because restarting the Docker daemon on a running node with a minikube confuses Kubernetes a lot. So this is responsible for the delay. And make a real operator out of this bash script. If I show you, I want to show you the source code, and you should not use it as an example for anything. This is the event listener, so I make it a little bit bigger that we can read it. What you see here is there is a get owner script which detects the owner of a pod by using simple kubectl. You can abuse kubectl as all the logic you need for a bash script. And this is the routine which starts a debloat cycle, and it is notoriously repeating things. And on the other side, you see the time until you think, yes, now I have caught all the files, is a simple sleep of 20 seconds, which is definitely not something you should assume about your workload. And then here, this is the line where you can see in a while loop, you can use a kubectl get event as the input for a bash loop, and then read the lines and simply say, okay, this is what we want to do. And this is the easiest way if you don't want to go into programming too deep and know a lot of bash to get an operator. But this operator is not really something you should persist. If we look on the other side in the unload pipe, so this is a process running inside Minikube. It's just creating a socket, and then this is a deep load cycle, and here is this buffs program used. You use buff shadow and the image name, and if it's ready, you use a buff deep load, and in between, this is just what I call an event queue. It's just waiting until the Docker daemon shows something is happening. So the good news is, yes, now it could be a proof of concept for an interesting project. The bad news is it will probably take some time. So the people who have created the original paper on that showed only interest. Yeah, we wanted to do this scientific paper. We don't want to give a production-ready version of it. And this means, yeah, we have probably to invest 1 year, 1 person year of time to make a real product out of it. And then you can get something which is not only debloating things, but if it's ready, it could upload it into an Harbor or in any other registry, that you get a real product on it. And this is basically what I wanted to tell you. So if you are interested in shrinking containers or have time or need a topic for your whatever master thesis, here it is. and all the support will come, but yeah, not ready for production. Thank you for your interest, and now I'm open for questions.
I will shamelessly ask mine first. I'm used to this topic for a couple of years now, and I saw a company called Rapid Fort that was doing kind of the same behavior, like shrinking to avoid to shrink the attack, the surface attack. Do you know about them? Have you tried them or?
There are a lot of examples. Some invented their own way of building containers, but they need some effort from the developer side. So in my experience, the main argument from the developer side is we don't have the time. Our PO does not give us the time to do it. We can do it, but we should definitely not do it in the next sprint, and then it goes down the project.
Got it. Let's go for the questions. Why debloat instead of building a minimal image like Nix?
How you remove files? Yeah, I cannot guarantee this effectively. This is so if you remove a file inside a container, it can be that later in the process it will be used by whatever situation. And if it's an emergency situation, then you go away with this, you remove the emergency trap of a container.
Yeah,
this can be dangerous. So you should be very aware of this. This is a typical situation. Yes, this is just an indicator what it removes. You get, by the way, you get a tar file with all the files, so you can even look into it and say, okay, I just want to keep these files, and I would definitely merge both approaches, that you get a list of files used, and then you can at least have a look into it, and then improve the situation by that.
Got it. All right. I think I missed the question. So, all right, let's go for the very first one that we have on the top. Why debloat instead of building a minimal image with Nix? Very first one on the top.
Yeah, this is a good alternative, but not all developers use and like Nix.
True.
This is developers are very diverse and they are very opinionated on what they like and what they not like.
All right, next one. Are scanners like Trivy able to properly pick up all remaining binaries libs with their versions and licenses after debloating?
Yeah, there is no package manager. This is true. So if you remove all these unused files, you also removing the copyright and the package information, and this means you should not propagate them to other customers. So this is something which has to be said. There was by Ian Coldwater and other from the Honk group, there was a talk in Amsterdam on the last, or one of the last KubeCons about, how is it called? Malicious compliance. So this effectively is the same as malicious compliance. You should use it only in your own house.
Yeah, the question was more like, so Trivy basically scans what you run based on its own database. So I think the question was like, if you remove binaries and libraries from the container image, what happens to the Trivy scan?
Trivy and also Gripe are using the metadata. And this process also removes the metadata. And this means effectively you are removing any chance of finding vulnerabilities, so you should do it before this procedure. So this is another of the open questions.
Okay. What about distro-less container?
I'm very I find anything which makes containers smaller very good. So distro-less containers are a very good approach to this, but also not everybody uses distro-less containers. And what I would actually recommend is, if you have a chance, statically compile your application and then make it available as one only binary. There are ways of statically compiling Nginx, so it's C code. You can add anything with C code. You can look for the flag and statically compile C code. You can do it with Go. Obviously, there are examples, so all the Google containers in this direction, but you cannot do it with Java or .NET. So having something which is completely statically compiled would be definitely favored about any other approach.
Got it. Okay, another question. Is the image every single time debloated when it enters the cluster? Should it not debload it in the pipeline?
It is deployed every time this process works. So the process effectively looks, is there a debloated image on this host? And then if it's already there, it does nothing. And if it would be on another host, then it would also be debloated there. So it's at the moment, the logic does not have any useful mean of saving the image to a registry, which would.
Okay, so there's not even a way to use a deployment pipeline to deploy it before running the container into the Kubernetes cluster.
If you can run this test with Docker only, you can use the original code and then use it. But then your test must run with this Docker only image, and this can be difficult in a more sophisticated situation.
Two last questions that we have. How big is a ASP core runtime after shrinking?
Which one?
The .NET 9.
I think it goes down by up to 80%, but I have not tested it for this. I should. So it's relevant. It's really much smaller, but I don't have the numbers at the moment.
Cool. One last question before the lunch. Would it be possible to contribute this back to Docker Podman instead of building a service around it? I would have asked the same question, to be honest.
Do it. Yes, it would be highly recommended, and the developers of the original version are open to it, but I think they have an academic background. So they learned about file systems. They are not learning about the entire cloud native or the entire container world, and this means, if somebody has spare time to contribute to this project or invent something similar and better, please do it. This is, I would say, this is the final frontier of security, just getting rid of these unnecessary libraries automatically.
Got it. We have a couple of minutes left. Do we have some questions in the audience, perhaps? Oh, there's one.
Hello, thanks for the talk. Did you know the tool Slim, and does it work in another way?
No, I did not use them. So do they? I'm pretty sure other tools are the same. How do they do it with files?
That's my question.
No, I don't know.
Okay, you don't know Slim. Okay,
But
I was interested is how this works.
yeah, I just in the beginning I started with dtrace or something like this because you also get some information about this, but the information never was complete enough to build an entire runnable image. So there might be other tools. Using the file system is the best approach in general I can imagine, but the orchestration of the entire thing is really not trivial.
For what I can add, because I've been using Slim for a couple of times, so the end goal is the same, but it behaves differently in the way that, so Slim can be integrated into a CI/CD pipeline, and then it shrinks, and then you have the ability to dynamically publish the shrinked image into your OCI registry or whatever. There's also some AI stuff that's built in the process. So I would say, well, I'm not really answering the question, but I would say that they behave the same. It's just that it's a different workflow. The goal is exactly the same, shrinking the image as much as possible, but the workflow is different. There's one that runs on the end cluster, and there's one that you can run on your pipeline or wherever you want.
Yeah,
that's basically it. Let's go for the last question that just appeared. What is your experience in the strongest argument to show people, devs, PO, that it is important to shrink images as much as possible?
Effectively, my strongest arguments I only have in critical infrastructure, because this means this is immediately endangering whatever our electricity grid or electricity or transport or harbor or finance. So it's immediately a risk which must be addressed. And then this is one of the DevSecOps things, and now we have in Europe the NIS2. So NIS2 makes the management responsible. You have to explain the management, you are responsible now. You have to do something. And the good news is in NIS2 there is also a feedback cycle. And then I hijacked this feedback cycle and said, okay, DevSecOps, as the US DoD is doing it, is a good approach to implementing this feedback cycle. And normally all the developers and operations people are on my side, but they need time. So the argument to the management is give your developers and operations people the time they need, and then they can implement it. Effectively, in a highly regulated environment, DevSecOps takes 20% of the workforce for 2 years, which is a lot.
True.
This is not something you can do in the afternoon, one day a week. So no, the entire team must be on board, and this is something you have to explain to the management. But now they are more and more they are understanding it.
Thanks a lot. Thank you all for the question. Thanks a lot for this great session. Don't forget to rate the sessions through the app first, please. Thomas, thanks a lot.
Thank you.
A big round of applause for our speakers, and well, let's have a lunch.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.